Hello everyone, Mr. Sichinga here. In this video, I'll answer question 12 from a 2024 Internal Mathematics Paper 1. So this question has two parts, A and B. And to start with, for A, this here is on index notation. And the question reads, solve the equation 3 to the power 1 minus 2x plus 4 equal to 5. So for solution for this part, I'm going to start by moving 4 to the right side. So this will be done as follows. So for A, it will be 3 to the power 1 minus 2x equal to, so there we have 5. Then when we take 4 there, it will be minus 4. And then subtracting what we have here gives 1. And on the left side, we have 3 to the power 1 minus 2x. Now for 1, since we want same bases on both sides, this one can be gotten if we express this side here as 3 to the power 0. Because 3 to the power 0 is the same as 1 and we want same bases. So this here will be written as follows: 3 to the power 1 minus 2x. Then this is equal to 3 to the power 0, which is the same as 1. Now, since we've got same bases, we can simplify the bases and equate the powers. And this is now going to be 1 minus 2x is equal to 0. Then to find x, we simply move 2x to the right side. And this will be 1 equal to 2x. Then divide through by 2 both sides. And this will give x is equal to 1 over 2. So this here is the answer for the first part, when we've been given to solve the equation 3 to the power 1 minus 2x plus 4 equal to 5. Then for the second part, B, this here is on mensuration, and the question reads, the diagram shows a sector A or B whose area is 231 centimeters squared and radius 14 centimeters. The angle subtended at the center is theta. So that is what that diagram shows. And then the question that is there is as follows: find the value of theta. Now, pi is 22 over 7. So for this part, I'll show the solution as follows. So area is 231 centimeters squared, then radius is 14 centimeters. And pi is 22 over 7. So take note of those measures that we've been given. So we start by writing the area of a sector. Formula for area of a sector, which is written as follows: area is equal to theta over 360 degrees, then times pi r squared. So this here is the formula for calculating area of a sector. Now on area, here we are going to substitute and put 231. And this is equal to theta, which we are looking for, over 360 degrees, then times pi is 22 over 7, then times radius, which is 14, times 14, since it is radius squared. So here we can simplify. So I'll start by simplifying. 7 into 7, this gives 1, and 7 into 14, this gives 2. 2 can go into 360, so 2 into 2 there, that is 1, and 2 into 360, here we get 180 degrees. Then we can also simplify here. 2 can go into 22, this leaves us with 11 here, and 2 into 180, here we get 90 degrees. Then for 14 and 90, 2 can go into 14, that is 7, and 2 can go into 90, that is 45. So what we are going to write is now the following. So this will be theta over 45 degrees. So since this is degrees, then times there's 11, there's 1, there's 7. So we just write times 11 times 7. So times 11 times 7. So this is the right side. And then for the left side, we just have 231. So now we can cross multiply here. introduce over 1 on the left side here, and when we cross multiply, this will be 231 times 45 degrees. Then this is going to equal to theta times 11 times 7. And then to get theta, I'll divide through by 11 times 7 both sides. So then this simply means this can simplify with this on the right side, and we are remaining with theta. So theta is equal to, so now for 11 can go into 231, 21 times. So 11 into 11, this here leaves us with 1. And 11 into 231, this one gives us 21. For 7 can go into 7, that is 1. And 7 can go into 21, that is 3. So here we are remaining with a 3. And this means that we have 3 times 45 on top. And then below it is just 1 times 1. So 3 times 45 degrees. This one gives us, if you multiply, 45 times 3. So here 3 times 5 gives 15. So we write 5 carry 1. Then 3 times 4, that gives 12. Then plus 1, that gives 13. So we are getting 135 degrees for the multiplication. So then this will mean that our theta is equal to 135 degrees. And this here is the angle for the sector. All right, so thank you so much for following through as I solved this question.